Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be looking at GCSE chemistry bond types. So this is an important topic because obviously that explains how the whole chemical reactions happen. Now we will today look at 3 different types of bonding that happen between atoms, elements and molecules. So without further ado, let's get started. First way that atoms or elements or molecules can bond is via ionic bonding. So this type of bonding is usually between, I'm going to write it down for you, between metal bonding to non-metal. So that's what usually happens in ionic bonding, and of course this is important because of how this happens. As ionic bonding is all about giving and taking away electrons, that's important to remember. Ionic bonding is all about taking electrons or giving electrons. Probably the best way to show it is by an example. So let's, for example, do this. So we have magnesium and we have 2 chlorine molecules. Atoms. And now they are going to react together to make MgCl2. Now let's work out ionic bonding. So, as we know from the previous video, by the way, if you are not confident on the different on the electron shells and the electron configurations, check out the video in the link in the description below. I go through all of that. So, first of all, let's establish what is the situation in the electron shells of each of these atoms. Now, there is a nifty little trick that tells you what electrons are in outer shell, because when it comes to bonding, the outer shell of each of these atoms is most important one. That's the one that stuff is going to be happening to. Now, there is a nifty little trick to figure out how many electrons in outer shell, and that is by simply looking at the group that this atom is in periodic table. So for example, magnesium is in a group 2 in periodic table. Therefore, it has 2 electrons in outer shell. Now chlorine is in group 7. So chlorine has 7 electrons in outer shell. And that goes for each one of these guys. So I'm going to label these guys, let's say, with green color. So we have 2 here, 2 here, 2 here, but only 1 there. And same situation is happening here. Okay. So what happened is we have magnesium in group 2 with 2 electrons in outer shell. We have chlorine in group 7, 7 electrons in outer shell each. Now, what is going to happen? Well, as we said previously, all these atoms try to make their shells full or empty. That's why they react. The whole reason for them reacting is to get their electron shells full or empty, the outer shell anyway. So what can happen here? Well, this is ionic bonding, so what is going to happen here is magnesium is going to give these electrons to chlorine. Magnesium is going to give this one here, and it's going to give this one here. So what happens at the end is we have magnesium with 0 electrons in its current outer shell, and we'll have 2 chlorine molecules with full outer shells of 8 electrons. So how do you draw it out properly? Well, to draw it out properly, we start with this, which becomes this. We have magnesium. I will explain this bit here in a second. And we have 2 chlorine molecules like this. And magnesium has an empty outer shell, so we leave it like this. However, chlorines have full outer shells. So chlorines have now 7 of their own electrons. So like this. However, they also have 1 electron from magnesium each. So 1 here and 1 here. And now they have full outer electron shells. So, however, what happened here? Now, if we go back to the balance between protons and electrons, we said that these atoms have the same amount of protons as they do electrons, in order to have net negative charges of 0. Net charge of 0. Now, that's electrons are negative, protons are positive, and they balance out to give us net charge of 0. However, what happened now is that we changed the alignment of these electrons without doing anything to protons. So that balance is going to be thrown off. So what happened? Magnesium gave away 2 negative electrons. So now it has 2 more positive protons than it does electrons. So it has net charge of 2+. What happened to each of these chlorine molecules? Well, each chlorine atom has gained 1 electron. So they have 1 more electron than they do protons. They have 1 electron too many, so to speak. So they have -1 charge, so they just have a minus here. Negative charge, -1. We could put -1, but the proper way is to just put in minus. Okay. So this is how ionic bonding works, and we showed the trick here where we know how many electrons in outer shell based on which group these atoms are in periodic table. An important thing to consider here is that these bonds are strong. So I'm going to write it down here. They are strong. Now, why are these bonds strong? Well, because now we have opposite charges. We have 2+ here and we have negative charges. And because these charges are opposite, these atoms attract each other very strongly to form very strong bonds. So that's why these bonds are strong. Okay, so this is it for ionic bonding. Now let's move on to another type of bonding, which is covalent bonding. 1 second, just let me align the paper. There we go. Okay, so now we're going to talk about covalent bonding. Covalent bonding usually happens between non-metals. So non-metal bonded to non-metal. That's when covalent bonding usually happens. And covalent bonding is going to be all about sharing electrons. So this is how to remember it. Ionic bonding is all about giving away electrons or taking electrons, whereas covalent bonding is when the 2 molecules sort of come together and just go, so let's share these electrons. And I will show you how it exactly works. It's all about sharing electrons. Now, let's do this the same way. Let's do this through an example. So we have water. Now, water is H2O, right? So water consists of 2 hydrogens. So we have 2 hydrogens like this and 1 oxygen. So let's draw out the outer shells of each of these guys. So we have two hydrogens, and they have, since they are in a first group, they have one electron in outer shell each. Now oxygen is in group 6. Therefore oxygen actually has 6 electrons in its outer shell. And the concept remains the same here. They are trying to fill or empty their outer electron shells. So now they need to figure out a way of doing this to have, either full or empty electron shells. So covalent bonding, as I said, is all about sharing electrons. So these guys all gonna share electrons like this. I'm going to show you. So they come together like this. We have hydrogen here. We're gonna have oxygen here like this, with a bit of an overlap here. And here we're gonna have another hydrogen like this with a bit of an overlap. So what happens? They share electron pairs. So we have hydrogen here contributing 1 electron to share, and it shares it with the oxygen here. And same happens for the other hydrogen molecule. Contributes 1 of its own electrons, but oxygen also decides to share. So we have 2 oxygens here, so we have 4 remaining, like this, that oxygen isn't doing anything with. They're not being shared, nothing. Okay, so now let's see what's happening. So for oxygen we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons in the oxygen outer shell. So oxygen is happy now because it has a full outer shell. And hydrogens are happy too because they have two electrons in its outer shell each. And now let's not forget that hydrogen has only the first electron shell, which only requires 2 electrons to be full. So hydrogens also have a full outer shell. So hydrogens are also happy. Now, that's how covalent bonding works, and again, these bonds are strong. Like this. Why are these bonds strong? Well, this is because now they are literally tied by the shared electron. They are literally tied by the shared electrons. So this oxygen can't go away because hydrogen's electrons are pulling it, and hydrogen can't go away because oxygen's electrons are pulling it. And these nuclei are positively charged overall, right? Because they have protons. So the positively charged nuclei attract these negatively charged electrons. So that's how the whole thing is stick together in a single shape. Okay. And another thing to mention is that the more pairs we share, the more bonds there are, right? So, as you know, some molecules could have double bonds. They could have double bonds. So, if here we have single bond, because 1 of each is shared. If we had 2 of each shared, we would have a double bond. If we had 3 pairs like this shared, we would have a triple bond, and so on. So, in covalent bonding, the amount of electron pairs shared tells you how many bonds we have. Do we have a single bond, double bond, or a triple bond? Okay, so this is it for covalent bonding. That's how covalent bonding works. So we had ionic bonding, which is metal and non-metal, and we have now covalent bonding, which is usually non-metal and non-metal. So this makes sense to cover the last type of bonding we'll be covering today. and that is metallic bonding. Now, metallic bonding, as the name suggests, is a bonding of metal molecules or metal atoms. Metal atoms, yeah. So this is all about metals. Now, how does this work? Metal bonding relies on delocalized electrons. I'm going to write it down for you. Delocalized electrons. This is an important term to remember. There we go. And how does this work? How does metallic bonding work? Well, we have a metal, I don't know, iron, for example, and it is a solid, isn't it? So we have atoms tightly packed together like this. They are sort of tightly packed together into a solid shape, somewhat like this. And so these guys here are actually nuclei of these atoms, positively charged nuclei. So I'm going to put pluses here. So all of these guys are positively charged. And what happens to the electrons? Now previously we had electrons arranged in these distinct shells. However, here we don't have this shelf. In metal solids, these electrons are said to be delocalized. And that's the whole theory behind metallic bonding. These electrons are not tied to specific shells or even specific atoms. They are free to move around. They are free to move around the whole solid, like this. So they are happy to move around as they wish. Whereas these protons, these nuclei, stay in place. And this is important because this is what gives metal its peculiar properties. This is exactly what gives metal its interesting properties. So, first of all, this is strong. These bonds are strong because these delocalized electrons almost act like glue. They're all moving around. They're all sort of moving around, and they're all pulling these nuclei together. So they act like glue. So they are strong. This is a very, very strong type of a bonding. And so this brings us to first property of metal. Metals are solid. Normally metals are solid because they have a very, very high melting point. You can melt them, of course, but you need to heat them up a lot. And that all comes down to very strong bonding that packs it really tightly and prevents these nuclei from moving about too much. So that's why metals are solid in room temperature, and you actually need to heat them up a lot in order to melt them. Now, another property of metals is that they conduce electricity. They are electricity conductor. I'm going to write it down here. Electricity conductor. Again, this is thanks to these delocalized electrons, because these electrons can move around, they can conduce electricity. They can move around, and they can transfer the electric current. They can move the electric currents because they are able to move around themselves. So that's why metals are great electric conductors. They are also great thermal conductors. Again, this comes down to these electrons being able to move. Because they're moving around a lot anyway, it is very easy to transfer the thermal energy onto them. It's easy to make them move around even more when you heat them up. So they can transfer that energy quite well because they can move around. Now, metals are also malleable. I'm going to write it down here. They're malleable. And that is important again because, I mean, this property here does not come. This property does not technically doesn't come from these electrons. Well, it kind of does because metals are packed. Metals are packed like this thanks to these delocalized electrons. Metals are packed in evenly arranged rows of atomic nuclei. So what this does mean is that these atomic nuclei, because they are so evenly arranged, so like this, I'm not going to put pluses in here for this, but you know these are positively charged. So if they are so nicely arranged in rows, they can quite easily slide over each other. So this one can go there, and then this one here can go like this. So metals are malleable because these atomic nuclei can slide over each other very easily, and therefore we can stretch these metals, we can hammer them into shape, we can roll them, we can make them into sheets. We can do a lot of things with metals without breaking them. That's what it means that the metals are malleable. Now, another property of metals is that metal alloys, when you combine two metal with another atom or a molecule, or when you combine metal with another metal, you make an alloy. And alloys tend to be harder than their constituent metals. Alloys harder. And why is that? Well, it comes down to this arrangement. Because the localized electrons provide this arrangement of the atomic nuclei, this arrangement in rows. Now, if we throw a spanner in the works, if we have these nuclei arranged like this, however, now we have either different metal, or for example in steel we can have a carbon molecule sneaking in right there, and that disrupts the whole arrangement. So that sort of disrupts it like this. You know, if we throw in another one here, that will disrupt the second layer like that somewhat. So it's no longer arranged in these neat even rows. And what that means is that they do not slide over as easily anymore. They cannot change shape as easily anymore. So they end up being harder. That explains why alloys are harder. So this is it for today, guys. We covered 3 different types of bonding. Ionic bonding for metals between nonmetals, usually. Covalent bonding for nonmetals with other nonmetals. Ionic bonding is all about giving or taking. Covalent bonding is all about sharing. And then we covered the peculiar metallic bonding, which is for metals, and it relies on delocalized electrons. It's all about electrons moving around throughout the entire solid. Thank you guys for watching these videos. I really appreciate it every time you guys watch it. If you want to stay up to date on daily videos on sciences, on maths and biomedical sciences, smash that subscribe button below. And if you liked this video, give me a big old thumbs up, and see you next time.